Hi students, welcome to MathSpy channel. Today we will going to discuss a important topic, that is continuity of a function. So first of all, what is the definition of continuity of a function? If f of x is said to be continuous, at x equal to a, then limit x tends to a, f of x is equal to f of a. So if f of x is said to be continuous at x equal to a, then limit x tends to a, f of x is equal to f of a, which means what? Limit exists at x equal to a and the function value is defined at x equal to a. If both are equal, then only it is said to be continuous at x equal to a. So what is the meaning of existence of limit is, so if left limit of the function is equal to the right limit, then only limit exists. So clearly left limit x tends to a minus f of x is equals to limit x tends to a plus f of x, then left limit is equal to right limit, then limit exists at x equal to a. So the existing limit is equal to functional value at x equal to a, then only it is said to be continuous at x equal to a. Now coming to the graph, for suppose if it is f of x, now we need to check for at x equal to a, and here we are having a value that is, for suppose, L. Now coming to the existence of limit, so as x value approaches to a from the left side, which means what? X tends to a minus. As x value approaches to a from the left side, then the function approaches to what? L. So coming to the left limit x tends to a minus f of x is equal to L. Now coming to the right limit, as x value approaches to a from the left side, so the right side, then function is approaches to L. So coming to the right limit x tends to a plus f of x is also equals to L. Now what is left limit is equal to L, right limit L. So left limit is equal to right limit, then the limit exists and the existing limit is equal to the finite quantity that is equal to L. So which is equal to L. So which means what? Limit x tends to a either from the left side or from the right side, f of x is equal to a finite quantity. So a finite quantity that is equal to L. And what is the value of the function at x equal to a? The function having a value that is L. So here it is very clear that value of the function is also equals to L. So left limit is equal to L, right limit is equal to L. From these two, limit exists at x equal to a, which is equal to L, and the value of the function is also equal to L. So all the three equal to L. So the function is said to be continuous at x equal to a. Now discuss some graphs on continuity. See, for suppose L, for suppose if it is M function. See, in case of whole, see the left limit for this function. So left limit x tends to a minus, so which means what? X tends to a minus. The function approaches to what value? L. So f of x is equal to L. Now coming to the right limit, as x value approaches to a plus, the function is also approaches to L. So here also limit x tends to a plus f of x is equal to what? L. So clearly left limit is equal to right limit, so that limit exists and the existing limit is equal to L. So clearly limit x tends to a, f of x is equal to L. So why? So left limit is equal to right limit. So that limit extends to a either from the left side or from the right side, f of x is equal to L. Now coming to the functional value, at x equal to a, function having a different value, that should be equal to m. So f of a equal to m. See, what is the limit value? L. What is the value of the function m? So clearly L is not equal to m. So here in this case limit exists and the value of the function is defined, but both are not equal. That's why this function is discontinuous at x equal to a. Now move on to the another case. For suppose so don't think that previous graph is same to this graph. Why? Because so here the value of the function is not there. So now check the left limit. So here limit extends to a minus f of x is equal to what? L. So why? Because the value of the function is approaches to L. Now coming to the right limit, what is the limiting position of this function as x value approaches to a from the right side? This is also equals to L. So very clear that the left limit is equal to L, right limit is also equal to L. So that if left limit is equal to right limit, then the limit exists and the existing limit is equal to L. So that limit extends to a, f of x is equal to L. But so what is the value of the function for this curve? So here there is no value of the function. So at x equal to a, the functional value is not defined. So why? Because there is no value for this function at x equal to a. So that f of a is equal to not defined. So what is the continuity of a function? So limit value is equals to the functional value, but here the limit exists but the function is not defined, so that these two are not equal, so that the function is discontinuous at x equal to a. So this is one of the reason of discontinuity of a function. Now next case, coming to the third case. For suppose so previous graphs are in case of whole and this is in case of broken f of x. So here this is having a value that is L and here this is what? M. Now check the continuity. So now move on to the left limit. Straight away limit extends to a minus f of x. Now tell me, as x value approaches to a from the left side, extends to a minus, the function value is approaches to L. So that is equal to L. Now coming to the right limit, limit extends to a plus f of x. So as x value approaches to a, so clear it is x equal to a. So extends to a plus. So what is the functional value? Is approaches to m. So that it is equal to m. Now what is left limit? L. What is right limit? M. So left limit is not equal to right limit. So clearly if left limit is not equal to right limit, limit does not exist. So if limit does not exist, so no need to check for the value of the function. Straight away it is said to be discontinuous at x equal to a. So that students, so please concentrate. So here we have three reasons. The first one is limit exists and function defined, but both are not equal. Now coming to the second one. So here limit exists. In the second case, limit exists but function is not defined. So this is the one of the reason for discontinuity of a function. Now come to the third case. So limit does not exist. So whether it is equal to the finite quantity or infinite quantity, whatever it may be, limit does not exist. So the first reason is limit exists and the function is defined, but both are not equal. And the second reason is limit exists but function is not defined. And the third reason is limit does not exist. Now, coming to the types of discontinuity, so we are having two types of discontinuity, that is, so two types of discontinuity, or else types of discontinuity. So what is the first type is removable type discontinuity. And the second one is non-removable type discontinuity. See, types of discontinuities. One is removable type discontinuity, another one is non-removable type discontinuity. So in this name clearly he said that removable type discontinuity, which means what? The discontinuity should be removed by replacing some equivalent value to the function, then the discontinuity should be removed. So here no need to possible remove the discontinuity, so that it is said to be a non-removable type discontinuity. So now move on to the removable type discontinuity straight away. Removable type discontinuity. So here also, in this case also, removable type discontinuity. So we are having two types of removable type discontinuities. The first one is, so what is removable type discontinuity? So here clearly limit exists. In this case limit exists, which means what? Limit exists, nothing but left limit is equal to right limit, but it is not equal to the functional value. Either the function is defined or not defined. So in this case, in this removable type discontinuity, it is very clear that limit exists, but it is not equal to the functional value, so that it is said to be a removable type discontinuity. So how to remove the discontinuity means, anyway limit exists, so that we need to give a proper value to the functional value, then it should both are equal, so that discontinuity should be removed. Now check what is happened here. What is the first type? That is isolated. So what is the meaning of isolated? See, isolated type discontinuity, the first one is, now check the graph. So this is also nothing but a hole type of hole at x equal to a. So as earlier, so we discussed about this graph also. See, isolated. So value of the function isolates from here to here, so moves from L to M. Now, so why it is said to be discontinuous? First, left limit. So limit extends to a minus f of x is equal to what? L. And coming to the right limit, limit extends to a plus f of x is also equal to L. So clear that left limit is equal to right limit, both are equal to the finite quantity, that is equal to L. So that here clearly limit exists. So limit exists and the existing limit is equal to L. Then what is the value of the function? So the value of the function at x equal to a is what? M. So f of a is equal to M. So limit exists, function is defined in this case, but both are not equal. So limit is not equal to the value of the function, so that it is discontinuous. And this type of discontinuous is nothing but isolated type discontinuity. Why? Because, so here, for suppose if you adjust M to this place, then the discontinuity should be removed. So is M is very closer to L, or else L equal to M, then it is said to be removable type discontinuity. So that here discontinuity should be removed by giving a proper value to the value of the function. This is the first type of removable type discontinuity. Now missing type. So missing point. So what is the meaning of missing point? Now, so here also check the graph. We also discussed about this graph also. See, why it is said to be a discontinuous first. Coming to the left limit, limit extends to a minus f of x is equal to what? L. And right limit, limit extends to a plus f of x is equal to what? L. Both should be equal to the finite quantity, that is equal to L. So in this case also, limit exists. Why? Because left limit is equal to right limit, both are equal to the finite quantity, that should be equal to L. So that here limit exists and the existing limit is equal to L. Now, what is the value of the function? So here there is no value for the function at x equal to a. So that the value is missing. So f of a is not defined. The value of the function is not defined. So left limit exists, but the value of the function is not defined. So that in this case both are not equal. Then it is said to be missing point discontinuity. So here also, if we give a proper value for the value of the function, then it should be equal to limit value is equal to the value of the function. Then it is said to be continuous. So by giving a proper value to the value of the function, then maybe it is said to be continuity. Now move on to the second type, that is non-removable type. So here also we have two cases. The first one is non-removable type of first kind, that is jump discontinuity. Jump discontinuity. See, this is a very important concept, that is, so here also we discussed about this one also, the meaning of jump. So here it is L, if it is equal to M, for suppose at x equal to a. So in non-removable type discontinuity, so clearly limit does not exist. So here in the first kind, which means jump discontinuity, so left limit, right limit, both are equal to the finite quantity. Those two are different. Both are equal to the finite quantity. So why it is finite quantity? Which means, for suppose if we check for left limit, which is equal to L, that is a finite quantity, left limit. Now coming to the right limit, limit extends to a plus f of x is equal to what? M, that is equal to the finite quantity. So both are equal to a finite quantities, two different finite quantities. Left limit is equal to L, right limit is equal to M, but both are not equal. So here limit does not exist. No need to check for the value of the function. But anyway, what is the value of the function at x equal to a? Function having, that is M. So f of a is M here. But it is very clear that the limit does not exist here. So it is discontinuous at x equal to a. So why it is said to be jump discontinuity? So the value, so graph is jumps from here to here. So here the one more important thing is, so in this particular cases we need to find the value of jump. That should be equals to modulus of right limit minus left limit. The value of jump is modulus of right limit minus left limit. So this is the formula for finding the value of jump. Now we will move on to the second type, that is essential type. Essential type discontinuity. So here in this case clearly limit does not exist, but both the limits or either of the limits, both the limits or either of the limits are not defined. So see, For suppose, let us consider a graph like this. Or else consider straight away consider a graph of f of x equals to 1 by x square. Straight away. See, as x value approaches to 0, see straight away, limit x tends to 0 minus 1 by x square is what? Not defined. And limit x tends to 0 on the right side, 1 by x square is what? Not defined. So, for suppose if it is positive infinity, let us take positive infinity. Here also it is positive infinity. So, don't think that these two values are equal. Why? Because the value is not defined. We don't know. So, how can you say that these two values are equal? Why? Because limit x tends to 0, 1 by x square is not defined. So, here also limit x tends to 0 plus 1 by x square is not defined. So how can you say that two not defined values are equal? So, that these two are not equal. So, clearly left limit is not equal to right limit. So, here it is very clear that if left limit is not equal to right limit, limit does not exist. So, and we need to take another. So, if you have a confusion, we will consider another graph. So, this is a graph of f of x equals to 1 by x. Now, so here it is very clear that as x value approaches to 0 from the left side, then 1 by x is what? Minus infinity. Minus infinity. Now, limit x tends to 0 plus 1 by x is equal to what? Plus infinity. Then, so in any way minus infinity plus infinity does not matter. So, both are not equal. So, and so both the limits are not defined, does not exist. So, here also left limit is not defined, right limit is not defined. So, limit does not exist. So, in this case also limit does not exist. So, that this type of discontinuities are called essential type discontinuity. So, we have four types of discontinuities. Then coming to the first one, removable type. In this removable type, so we have two types, that is isolated and missing point. So, coming to the non-removable type, we have two types again, jump type discontinuity and essential type discontinuity. Okay students, so these are the concepts of continuity of a function. In the next class, we will discuss about the problems. Okay students, thank you.